Come with me on a journey to the far reaches of our solar system. Out here, beyond the rocky inner worlds and the gas giants we know so well, lies a different kind of planet. It's a place of incredible cold and mysterious beauty. We are heading towards Uranus, the seventh planet from our sun. It's a world that beckons us, full of secrets waiting to be told. Prepare to be astonished by this distant, icy outpost. Imagine our solar system as a vast cosmic city. The sun is its bright, bustling center. Closer to the sun, we find planets like Earth, Mars, and Venus, but Uranus lives far out in the cosmic suburbs. It's much more distant than Jupiter or Saturn, our more familiar giants. This great distance means Uranus receives very little sunlight, and that, my friends, makes it an incredibly cold and fascinating world, an ice giant in the grand theatre of the cosmos. Uranus is truly enormous, a giant compared to our home planet Earth. You could fit about 63 Earths inside it. Think about that for a moment. 63 of our worlds, all tucked neatly inside this one colossal sphere. Yet, for all its size, it's not the king of giants. Jupiter and Saturn hold that title. Uranus, however, possesses its own unique charm, its own special place in the celestial hierarchy, a testament to the diversity of worlds our universe can create. We call Uranus an ice giant. This might make you think of a planet made of solid, frozen water like a gigantic snowball. But the reality is far more complex and intriguing. The ices within Uranus are not just water ice like we know it. They are a mixture of water, ammonia, and methane. These materials are compressed under immense pressures and temperatures deep inside, forming a strange, slushy, almost fluid, icy mantle. It's a different kind of cold, a different kind of giant. For millennia, humanity looked up at the night sky. Our ancestors charted the movements of the stars and planets. They knew of 6 wandering lights: Mercury, Venus, Mars, Jupiter, and Saturn. These were the known planets visible to the unaided eye, companions in our cosmic dance. They were woven into myths, legends, and the very fabric of early astronomy. Uranus, however, remained a secret, patiently waiting its turn for discovery. Believe it or not, Uranus is actually bright enough to be seen without a telescope, but only just. You would need a perfectly dark night, far from city lights, and exceptionally keen eyesight. Ancient stargazers likely spotted it many times throughout history, but it moves so slowly against the backdrop of stars, so faintly, that they mistook it for just another distant, unremarkable star. It was a planet hiding in plain sight, a cosmic wallflower. The invention of the telescope changed everything. This marvelous instrument, a tube with lenses, brought the distant universe closer. It magnified the faint and revealed the unseen. Galileo Galilei, with his small telescope, revolutionized our view of the cosmos, showing us Jupiter's moons and Saturn's rings. This new power of observation set the stage for discovering more of our solar system's hidden members. The universe was about to get a little bit bigger. The eventual discovery of Uranus was not just a matter of finding another planet. It was a profound moment. It shattered the long-held belief that the solar system ended with Saturn. It demonstrated that our cosmic neighborhood was more expansive and more populated than we had ever dared to imagine. It opened the door to the idea that there could be even more planets out there, waiting in the darkness. The quest had just begun. The honor of discovering Uranus goes to a truly remarkable individual, William Herschel. Born in Germany, Herschel was not initially trained as an astronomer. His first passion was music. He was a talented musician and composer, playing the oboe, violin, and later the organ. He even moved to England to pursue his musical career. But another passion burned brightly within him, an insatiable curiosity about the night sky. Herschel wasn't content with just gazing at the stars. He wanted to see them more clearly, to explore their mysteries. So he taught himself how to grind mirrors and build his own telescopes, and he was very good at it. His homemade telescopes were among the largest and most powerful of his time. Night after night, from his garden in Bath, England, he meticulously scanned the heavens, driven by a desire to understand the universe's grand design. Then came that fateful night, March 13th, 1781. While systematically observing stars in the constellation Gemini, Herschel noticed something peculiar. One faint object appeared different from the surrounding pinprick stars. Instead of a sharp point of light, it looked like a tiny fuzzy disk. Intrigued, he observed it over several nights. He saw that it moved relative to the background stars. This was no ordinary star. At first, Herschel suspected it might be a comet, one of those icy wanderers that grace our skies. He announced his discovery as such. But as other astronomers began to track its orbit, they realized its path was more circular, more planet-like than cometary. Calculations soon confirmed it. Herschel had found a new planet, the first to be discovered since antiquity. The solar system had expanded thanks to the keen eye of a musician turned sky watcher. So what lies beneath the beautiful blue-green clouds of Uranus? What is this ice giant truly made of? It's a world vastly different from our own rocky Earth. Uranus doesn't have a solid surface you could walk on. Instead, it's composed mostly of fluids and those exotic ices we mentioned earlier. It's a realm of incredible pressures and surprisingly intense heat deep within its core, despite its frigid outer layers. At the very heart of Uranus, scientists believe there's a small, rocky core. This core is thought to be roughly the size of our Earth. Imagine our entire homeworld, with its mountains and oceans, compressed into the central region of this immense planet. Surrounding this rocky kernel is where things get truly strange. There lies a vast, deep mantle, not of molten rock like Earth's, but of super-pressurized, hot and dense icy materials. These ices inside Uranus are primarily water, methane and ammonia, but don't picture them as solid blocks of ice. Under the crushing pressures and high temperatures deep within the planet, thousands of degrees Celsius, these substances behave like a bizarre, hot, electrically conductive fluid. It's more like a thick, swirling, superheated ocean than anything we'd recognize as ice on Earth. It's this unique internal structure that defines Uranus as an ice giant. Trying to land a spacecraft on Uranus would be a one-way trip to oblivion. There's no solid ground to touch down on. Your probe would simply sink deeper and deeper into the increasingly dense atmosphere. Eventually, the immense pressure would crush it, and the intense heat from the deep interior would vaporize it. Uranus guards its secrets well, a testament to the extreme conditions that can exist on other worlds. Section 5. The Hazy Blue Veil, Uranus's unique and chilly atmosphere. The part of Uranus we see with our telescopes, its visible face, is actually the top of its incredibly deep atmosphere. This atmosphere is a vast ocean of gases, primarily hydrogen and helium. These are the two lightest and most abundant elements in the entire universe. They are the same primary constituents that make up the atmospheres of its larger cousins, Jupiter and Saturn. But Uranus has a special ingredient that gives it its signature look, that beautiful, serene blue-green color of Uranus. It comes from a gas called methane. Methane gas in Uranus's upper atmosphere absorbs the red and orange light from the distant sun. At the same time, it scatters and reflects the blue and green wavelengths of light back out into space. So when we look at Uranus, we see those lovely cyan hues, a calm and cool color for a calm and cool-looking world. It's like a cosmic artist chose a specific palette for this distant giant. And when we say cool, we mean it. The atmosphere of Uranus is one of the coldest in our solar system. At its cloud tops, temperatures can plummet to an astonishing minus 224 degrees Celsius. That's minus 371 degrees Fahrenheit. This extreme cold is partly because Uranus is so far from the sun's warmth. But there's another mystery. Uranus gives off very little internal heat compared to other giant planets, making its upper atmosphere exceptionally frigid. Scientists believe Uranus's atmosphere isn't just one uniform layer. It likely has distinct cloud decks, stacked one on top of another. The highest clouds we see are probably made of crystals of frozen methane ice, forming a thin, cold haze. Deeper down, there might be clouds of ammonia ice, and even deeper still, perhaps clouds of hydrogen sulfide, the gas that smells like rotten eggs. It's a complex, layered sky, hiding many secrets beneath its placid, blue-green exterior. Section 6. Wild winds and ghostly storms, the surprising weather of an ice giant. You might imagine that a planet so far from the sun, so cold and seemingly featureless, would have very calm weather, but the universe often surprises us. Uranus, despite its serene appearance, experiences some truly wild weather. It boasts some of the fastest winds in the entire solar system. These winds can whip around the planet at speeds exceeding 900 kilometers per hour. That's over 560 miles per hour, faster than any hurricane on Earth. These powerful winds on Uranus generally blow in an east-west direction, parallel to the planet's equator, similar to the jet streams on Earth, but far more intense. What drives these furious winds on such a cold world, which lacks a significant internal heat source driving up from below, is still a puzzle for planetary scientists. The faint sunlight it receives and its slow internal heat leakage must combine in complex ways to power this extreme atmospheric circulation. For a long time, Uranus appeared as a mostly blank, featureless blue-green ball through most telescopes. When NASA's Voyager 2 spacecraft flew past in 1986, it saw only a few faint cloud features. This led to its reputation as a somewhat bland planet. However, with the advent of more powerful instruments like the Hubble Space Telescope and advanced ground-based observatories, we've started to see more dynamic activity. Uranus, it turns out, isn't so sleepy after all. These advanced observations have revealed the presence of enormous storms and bright cloud features that can appear and disappear over time. Some of these storms can be as large as continents on Earth, swirling masses of icy particles and exotic gases. They appear as bright spots against the planet's more uniform blue-green canvas. These are not your everyday rainstorms. They are colossal weather systems raging on a distant ice giant, a testament to the dynamic nature of planetary atmospheres. Section 7, the tilted wanderer, Uranus, our solar system's sideways planet. Now let's talk about one of the most peculiar and defining characteristics of Uranus. It's a real oddball in our solar system family. Most planets, including our Earth, spin like a top as they orbit the Sun. Their axis of rotation, that imaginary line running through their north and south poles, is more or less upright or tilted just a little bit. Earth, for example, has an axial tilt of about 23.5 degrees, which gives us our seasons. Uranus, however, throws this convention completely out the window. Its axial tilt is an astounding 98 degrees relative to its orbital plane. This means Uranus is essentially rotating on its side as it journeys around the Sun. Imagine a spinning barrel rolling along its path rather than an upright spinning top. No other planet in our solar system has such an extreme tilt. This makes Uranus truly unique, a celestial curiosity that begs for an explanation. So why is Uranus lying on its side? The most widely accepted theory is that early in its history, billions of years ago, when the solar system was still a chaotic place, Uranus suffered a colossal impact, or perhaps a series of impacts. A massive object, possibly an Earth-sized protoplanet, may have slammed into the young Uranus with tremendous force. This cataclysmic event could have literally knocked the planet over, forever changing its orientation in space. This extreme tilt isn't just a quirky detail. It has profound consequences for the planet. It dramatically affects how sunlight reaches different parts of Uranus throughout its long year. It leads to the most extreme and bizarre seasons imaginable, far stranger than anything we experience here on Earth. This sideways orientation is a key piece of the puzzle in understanding Uranus's atmosphere, its weather, and its overall evolution as a planet. Section 8. Decades of day and night, the extreme seasons on Uranus. The radical tilt of Uranus means its seasons are unlike anything else in the solar system. They are incredibly long and incredibly extreme. Remember, Uranus takes a leisurely 84 Earth years to complete just one orbit around the Sun. That's one Uranian year. Because of its sideways tilt, this long year is divided into seasons that last for about 21 Earth years each. Imagine a summer that stretches for 2 decades, or a winter that lasts just as long during the summer solstice at one of Uranus's poles. That pole points almost directly towards the Sun. For about 21 long Earth years, that polar region experiences continuous daylight. The Sun never sets, it just circles around in the sky. Imagine decades of unending sunshine, albeit a very faint and distant sun. It's a polar day that lasts for a generation. This constant, though weak, solar energy input has significant effects on the atmosphere in that region. Meanwhile, at the other pole, the situation is the exact opposite. That pole is tilted away from the Sun, plunged into a continuous 21-year-long winter night, complete darkness year after year with no sunlight to warm it, an incredibly frigid and long polar night. As Uranus continues its slow journey around the Sun, the situation gradually changes. The regions around its equator experience more rapid day-night cycles, but even these are unusual compared to Earth. For someone standing, hypothetically of course, near Uranus's equator, the sun's path across the sky would be very strange. For many years, the sun would appear to rise and set as the planet spins, but as the planet moves in its orbit, the sun would appear to trace a path closer to the poles during the solstices, and more directly overhead during the equinoxes when the sun shines directly over the equator. The sky on Uranus would be a constantly yet slowly changing spectacle. Section 9. Uranus's faint rings, icy moons, and the endless quest for knowledge. Uranus is not alone in its cold, distant orbit. Like Saturn, it possesses a system of rings. However, Uranus's rings are quite different from the broad, bright, icy rings of its more famous neighbor. The rings of Uranus are narrow, faint, and dark. They are composed of relatively large particles, ranging from dust-sized to several meters across, that are as dark as charcoal, making them very difficult to see from Earth. They were only discovered in 1977, quite by accident. Beyond its enigmatic rings, Uranus is also the shepherd of a fascinating family of moons. At least 27 moons are known to orbit this ice giant. Keeping with a literary tradition, these moons are not named after figures from Greek or Roman mythology, as is common for other planets. Instead, they bear the names of characters from the works of William Shakespeare and Alexander Pope. Titania and Oberon are the largest, but even they are much smaller than Earth's moon. These moons are intriguing worlds in their own right. They are primarily composed of a mixture of rock and ice. Some of them, like Miranda, display incredibly bizarre and jumbled terrains with giant canyons, terraced layers, and chaotic surfaces. This suggests that Miranda might have been shattered by a massive impact in its past, only to reassemble itself from the debris. Each moon holds clues to the history and evolution of the Uranian system. Uranus, the sideways planet with its frigid atmosphere, extreme seasons, faint rings, and curious moons, remains a world of profound mystery and allure. Studying this distant ice giant helps us understand the diverse ways planets can form and evolve. It challenges our understanding of planetary dynamics and atmospheric science. Uranus reminds us that our solar system, and indeed the entire cosmos, is filled with wonders still waiting to be explored, still beckoning us to look deeper and ask more questions. The journey into the unknown continues.